So in a case like this, you have a fraction that's hiding from you. You see that? It's that 1/5 that's inside the parentheses. So our mission in step one is not to kill that fraction. Our mission in step one is just to get it out in the open so that we can eliminate it. All right. So generally what I'm going to do in a step like this, because I'm not scared, you're not scared, is we're just going to take the -2 and we're going to distribute it through the parentheses like here and here. Okay. And you'll want to practice this step a lot and just let me know if I can help you with it. So when the -2 multiplies by the x, we of course just get -2x. And then this is the step that people usually don't like. So we got to do this in steps. The -2 is going to hit a positive 1/5. So before I even figure out the answer, I want to make sure I understand that it's negative. So I want to always put that down before I forget. Do you know how to do 2 times 1/5? The trick is to think of 2, and eventually you won't have to go through all this. You'll just know what to do. But the trick is to think of the number 2. And notice I'm not saying -2. Once I figure out the answer is negative, I don't care anymore, right? So the 2 you need to think of or write down as 2 over 1. And then when it multiplies by the 1/5, this is up here in the corner is what it looks like. So then we ask ourselves, can anything reduce while I'm here? And the answer is, well, no, 2 and 5 can't reduce. So then you just multiply across the top and the bottom, and you just get 2/5. You okay with that? 100%? Okay. And then I'm going to copy down my plus 5x. And while I'm here, I'm going to go ahead and also, oops, I should probably copy down the 4. You see this 4 right here, how he's not really attached to anything, so he's just going to get copied. And then the next math that happens is right here. And this is the part that nobody likes, but doesn't mean we don't have to know how to do it. So our first multiplication problem, excuse me, is right there. And we're going to use the same trick again. So it's a negative times a positive. So I can put down my negative sign. And now I don't have to worry about that anymore. And when we have to do 4/5 times 3, because that's really the math here, I'm going to write it down as 4/5 times 3 over 1. That's your go-to, is always make whole numbers into fractions. It's going to answer so many math questions for you. And then again, we look across and we see that no one from the top can reduce with anyone from the bottom, right? So what are we going to get? And then let's just make sure we stick an x on there. So it's 12/5 of x, like that. And then, I mean, we're going to do it again. And then we're going to take this negative and we're going to multiply it. And again, my thinking with you is we should always get the sign part out of the way first. And then we don't have to talk about it. So that's another negative times a positive. So it's another negative. So if you set that up without my help this time, put the 7 over 1, what are you going to get? I'll be right with you, Cruz. Over 5, right? Because we got the 5 and the 1 going across the bottom. I don't think that's anything that we can't do, right? It's a little bit annoying, but now the good news for us, the bad news is we have fractions. But the good news is they're out in the open now, and we can take and do our thing with the big monster parentheses and hit it. What are we going to multiply by? Right, because we only have one flavor of fraction that we have to kill. So this step should go smoothly. We're either going to be multiplying regular numbers, which is just old school, like 5 times 2, 5 times 4, stuff like that, or we're going to be multiplying to kill fractions. So we're going to have 6 multiplication problems that we have to do, because that 5 is going to smack everybody inside. So what's the first one going to be? You got to go right here. What's that first multiplication? No, it's not 10. It's -10. So we're going to put -10x. Now I'm not going to keep drawing arrows, but every time the 5 goes, he goes to the next guy in line and multiplies. Do you know, I'm going to draw one more arrow. Do you know what happens? Really cool thing happens with that multiplication right there. The 5s get crossed out. So it's really noisy. So the fives go bye-bye. Good. And that leaves us with, again, it's a positive times a negative. So I put my negative and I just put the 2. All right, keep going. Go 5 to the next guy. What do you get? It's not division this time. That's what I was saying. This is just, yeah, 25. This is just regular. There's no canceling here. It's just 5 times 5 is 25x. So we put a positive or a plus sign, 25x, and let's keep going. Go to the fourth guy. What do we get? I still can't hear you. I'm so 20. Good. It's just really loud in here, so I'm sorry. But yeah. So 5 times 4 is 20. And then we're going to go again, and we're going to put our minus sign, and what do we get? So minus 12x, and go again. What do you get? Minus 28. And see, what we've done now is 2 uncomfortable steps that got us to a point now where we can solve this equation in peace and quiet without fractions, right? So what would you do next? Which ones? The negative 10x and the 25x. So add those together. What do you get? Nope. It's not 10 plus 25, Cambry. It's negative 10 plus 25. That's a big difference. Saying those negatives is huge. Own them. Respect them. If you owe me $10, that's negative 10. If you pay me 25, I'm going to give you how much back? That's right. So it's positive 15x. On the right side, which like terms are you going to combine? So what are we going to get when we do the 20 and the minus 28? Nope. You're saying to me that if you have $20 in your bank account and you write a check for 28, that you still have 8 in your account. You've really got to own this whole. You've got to come to grips with knowing where 0 is on a number line, and 0 is the middle guy. And if you're at 20 and you take away 28, you have to go past 0, don't you? That means it's negative. How negative is it? If you have $20 and you spend 28, you owe the bank some money, right? It's negative 8. And that's something you got to train in. I'm telling you, I spend so much time every year because you guys have spent years before you've met me thinking that you can just, oh, 8, negative 8. That will make a difference between a 95% in my class and a 65. You've got to own every little movement around the number 0. Do I go positive? Did I cross it? Do I go negative? Did I cross it? That has got to just get stuck. So 20 minus 28 is negative 8. And then we're going to copy down the minus 12x. We've done like 20 math problems, and every one of them had to have gone right to get here. Every one of them. No missed negatives. No, I was close. Perfect everything. What's next? Add the 12x. Is that what you meant? Good. So let's add 12x to both sides. So yes, we're going to add that 12x because now that we're going across the equal sign, we have to do the whole opposite thing. So we're going to add it right here, and we're going to add it right here. And that's going to give us how many x's over here? Nice. So I'm going to start writing up here a little bit because I'm out of space. So I'm going to write 27x minus 2 equals negative 8. What's next? Add 2 to both sides, right? So remember, make sure you really use those words, both sides, both sides. To make this work, what I'm legally doing is I'm adding 2 to both sides of the equal sign. And those will cancel, and I bring down my 27x. Now, think of your number line, kiddo, okay? Don't say anything crazy. Negative 8 plus 2. Nope, you went the wrong way, dude. You're saying negative 8 minus 2 more. Remember, minus means I go deeper. Plus means I'm climbing out. So if you're in debt to the bank, yeah, if you owe the bank $8, but you go and plus 2, you add 2 to your account, you still owe them, but now your debt gets smaller, right? Negative 6. We got to divide by 27, right? And again, we're going to say the words both sides. That's really important. We're doing it to both sides. That's what makes this legal. And now our answer is on the board. And if we type in that answer down there in the corner of the TV, it's going to be wrong, even though we've done nothing wrong. Do you know why? No, improper would just mean that the top is bigger than the bottom, and that's not against the law, right? It needs to be reduced. So what can you divide the top and the bottom by? I'm still wrapping up a problem here. I'm almost done. Okay. Sorry. So I got to press on, but I'll just tell you, we can divide those numbers both by 3. And that's what we have to do. So if we take the top number divided by 3, so it's negative. And then if we take the top divided by 3, we get 2. And then the bottom divided by 3, we get 9. I don't know how many, I didn't count them, but there has to have been 25 or 30 math problems. That's the thing about algebra. And that's why I stress at the beginning of the year that you cannot be close or pretty good at your basics with adding and subtracting and times tables. It has to be 100%, because there's so many things. Just so hard to do 30 math problems in a row and get them all right. Who is next? Cruz, did you get into Delta? Okay, good. Yeah, I think you were Rutley. I don't care who. You want some help? Sure. Not sure where it is. This is a very unscary problem to me, just as someone who sits over here on this side of the desk. This one doesn't worry me. I assume you distributed your negative and got negative 5/2 of x minus 1. Is that a correct assumption? Everything? Nope, we can't be close. That's the thing. I'm telling you this. So you didn't put minus 1? Okay, so let's understand. This negative hits this 5/2 and makes it negative. And then the negative hits this plus 1 and makes it minus 1. That change has to happen when you distribute a negative. So you found your boo-boo? I mean, if you missed a negative, that's your boo-boo. I mean. So I would just by 10, right. And when we multiply by 10, then we're going to do our fraction killing, that little hook thing I showed you. So like on the first fraction kill, we go 10 divided by 2 is 5 times 5 is 25. So we put negative 25x. And then you don't have to fraction kill on the second step because it's just a dumb number times a dumb number. So 10 times negative 1 is just negative 10. The third one is a fraction kill, Rutley. You see it? Across the equals, you see that fraction kill? What are we going to get? Or it's not across the equal sign. I'm sorry. The last one before the equal sign. No. What is 10? Follow my green arrow. What is 10 divided by 5? What is 2 times 2? So I'm going to put minus 4. Don't move past that until you own it. Don't casually just say, okay, I kind of get it. Let's stop and talk about that. Do you understand why it's 4 and not 20? If you guys, I'm just recording basically the whole class, so I have no idea who will watch this. But listen, the thing you cannot be slow at is fraction killing. If I'm fraction killing with, say, the number 12, and my arrow goes in and I encounter a number like 3/4, This has to be, I want this to be so fast that you know that the answer is 9 before your pencil even has a chance to catch up. And I don't want you to leave this room today until you understand this like massive. 12 divided by 4 is 3 times 3 is 9. Boom. It should just be lightning fast. Draw that little fish hook in your mind and picture yourself. And you can remember down and divide both start with D. So when you go down the slope, you're dividing and then you swing around and multiply. Let's practice it again. So if I had like 10 times 4/5 quickly, what is it? What is it? It is 8 because 10 divided by 5 is 2 and 2 times 4 is 8. I'm talking to you because you said 40, so you should be listening. You should be listening. That's, yeah. And you know that. That fish hook, call it whatever you want. If you don't want to call it a fish hook, I don't even care what you call it. But it's how you fraction kill, and it's fast. Let's go again. 15 times 2/5. If I'm fraction killing quickly, what do I get? It is 6. It is undeniably 6 because 15 divided by 5 is 3. 3 times 2 is 6. That has got to be lickety split. Now, I will say this, and I'll say this on the recording. If you do not know your times tables, then you have other problems that you need to solve. I am not your 4th grade teacher, and I am not your parent who can drive you around town and quiz you from the front seat. But you can advocate for yourself and get an app on your phone or go buy some flashcards, or I can loan you some flashcards. Because if you don't know 15 divided by 5, then you have some other fish that you need to fry on your own time. I come into this teaching 9th grade math with the assumption that you know your times tables. And if that's not true, that doesn't mean you're a bad person. It just means you've got some things to take care of. Because all year, every problem that takes the kid sitting next to you 25 seconds is going to take you a minute and a half because you're over there mooking around, punching buttons and looking things. Ain't nobody got time for that, as Sweet Brown would say. Brutally, are you with me, bro? Good. Yeah, Landon. So yours is mildly uncomfortable. But the one thing I'll say about yours is that I don't have to distribute. Can you see anything good about your problem? Yes. Boy, I could not have expected a greater answer than that. Because the fractions are both out in the open, hang on a second. I need to pause this again. When we multiply by 5, the fractions are both going to go kaput. So you should have gotten negative x or negative 1x equals x plus 10 minus 6x. Do you see why when I killed that second fraction, I didn't put the remnant there after the 5 divided? When I fraction killed, what would the remnant have been? This one right here. What would it have been when the 5's canceled? And 1s are pointless, right? So when I get a 1 left over glued to parentheses, I just go, I don't need that. So that's why I wrote it the way I wrote it. Do you understand that? What do we do now? That's what we do. Which one specifically? You got it. Good job, man. And what is on the right side? And again, this is just the basic skills that all year gets in the way. What is this 1x? What is the 1x minus the 6x? Good job. So we're now left with negative x equals negative 5x plus 10. You asked for some help on this. Have I gotten to the part yet that stumped you?
Yeah,
Yep.
I actually understood it. Multiply the 5 by the 6.
Oh, you should have, and I actually messed up. So thank you. So you didn't make a mistake. I did. Thank you for pointing that out. I like it when I record my mistakes. This is rad. I forgot that the 5, I got so wrapped up in talking to you about the 1 that I forgot. It actually goes there as well. I'm so sorry for that. That's not a mistake. That's my mistake. So that's going to change some things for us, isn't it? I apologize for that. How many X's are we going to have on the right now?
29.
I'm sorry, what? No. If you say 29, yeah, you're off by 58 when you say that. That's negative 29. So we have negative 29x. What's the next step? Yeah, it's by adding 29x to both sides. So we wind up with how many x's? Right? So we get 28 x's equal to 10. And then what do we do? Yeah, and you'll get a fraction that can, I think, pretty obviously be reduced and you'll be done. So that's that. Yeah, Addie, you were waiting for a while, a long time ago. Do you want some help? Okay. So the good news on yours is that the bad news is you have a fraction hiding from you. But the good news is that the distribution required to get it out in the open is really easy. What are we distributing into that annoying set of parentheses? No, 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 no. Let's be clear. This x is not attached to the parentheses.
Oh, I know.
Just a negative sign. That's really important because that's going to make this super easy for us because now I'm going to take this negative x and I'm just going to copy it because it doesn't get to play in this step. Now, what I'm going to do is take that negative sign, and do you know what happens when you distribute a negative through parentheses? Yeah, or positives into negatives, right? Basically, it just goes in and says, whatever you used to be, I'm going to make you different, right? So what are we going to get when it goes through there? Nice. And so since it's positive x, I do need to put an operator like a verb in front of it. So I'm going to put plus x, and then I'm going to put plus 1/2. So far, so good. And then on the right side, I am just going to copy everything down because there was no work I had to do, of like no parentheses or anything. So are you comfortable with that step? Now what? You can. Which ones? How many will we get? Good. And honestly, that's not the answer I was expecting. But in this case, it's a really good answer, Addie, because normally I would say that would have been a good time for us to put on our monster brackets and go fraction killing. But you're smart to see that those two x's, if we put them together, here's a nice bonus for you. They just disappear, which is really sweet. That's going to save us some time. So good thinking. Now what should we do? Right. Good thinking. And what are we going to multiply by?
Okay.
You're fine. Good job, kid. So we're going to multiply by 10. And I'll try not to mess up like I did with Landon. We're going to remember, we're going to multiply every one that we can see, right? So the 10 is here. And let's practice that. Remember, the hook kill. So you go 10 divided by the bottom 2. What do you get? And then swing that answer around and multiply by the top. 5 times 1 is. So we just put 5. Let's practice again. So my second arrow here, we know is going to be negative. So I would put that down first if I were you. I like to write down my negatives just so I don't forget like a ding dong, because I do really funny things sometimes. Now, fraction kill again, what do you get? Yeah, the kid. So we put 4x, and then fraction kill again. What do we get? 5. At this point in time, the fraction killing is complete. We've done 2 steps, and we are right where we want to be. What is the only next step we could do? You got it. So I'm going to show my work. I'm going to put a -5 to make that one go away. And I'm going to wind up with negative 4x on this side. And 5 minus 5 is 0 on this side. And then I'm going to divide by. And what am I going to get? It would. Yeah, because when you divide, whenever you get an equation that structurally comes down to look like this one, it could say 0 equals 1,000,000x. And at the end of the day, whatever I divide by honestly doesn't matter because 0 doesn't care what it divides by. It just says, I'm just 0.
That's when it's there.
Combined by terms.
Zero is
All of this.
zero is just a number. Don't be scared of zero. Yeah. Need some help, Jackson?
Okay, so that's on one. So it's a. So it's in the negative. Version.
So this
So that's on one.
is one of my least favorite kinds. As the guy that gets paid to teach this to you, this is the one that I just feel the worst about because those fractions that are hiding in there, unless you and I want to go to great lengths, it's not worth it. So I've been calling this the suck it up buttercup step, like the just do it, right? So what we're going to have to do is we got to distribute that 3 through the parentheses. And on the right side, Jackson, I'm not scared of that distribution because I'm just distributing a negative. That's easy. So here we go. On the left side, your -10 just copies down. Now, let's see how you are with your fractions. When we do 3 and we multiply it by a fourth, what do we get? So I'm going to put plus 3/4 of x. How about that second distribution? What's 3 times 1/2?
No.
And again, I got a lot of noise in my world, so I need you to really yell at me, okay? Yeah, just like really yell at me because there's a lot going on right now. So I heard you that time, but just really go after it when you guys are talking to me because there's ruckus in here. And now I'm going to copy down my equals sign.
Oh, wait, you know what?
And I'm also going to copy down my -x. And then this is the part where we just do what?
You have 30 divided by 6, not 6 divided by.
We're not fraction killing right now, bro. I need to get rid of those parentheses on the right-hand side. Understand what I'm trying to say to you is in problems like this, our objective in step 1 is not to kill fractions. Our objective is to get everyone out of the parentheses so that we can kill fractions. You got that? So when that negative distributes into the second batch, what does the x become?
So it's into 2.
And what does the -5/2 become? Right. And now everyone is out in its open season. What are we going to multiply by? Right. Multiply by 4. Now pay attention because I've already made this mistake once today. So, I mean, it happens. Multiply everybody that you see. If it's out in the open, smack it. So what are you going to get? Good job, my man. And then don't forget that the 4 also has to go to the other side. So we get -4x minus 4 more x's plus what? Ballard, do you think you got it from here? Combine like terms on the left. I'll walk through it with you, but let's go real fast. So on the left side, when you put your like terms together, what do you get? Say it again. No, -40 plus 6 is not -36. You did -40 plus 4. -34. And on the right side, Jackson, what do we get? Yeah. Now who should we move? You say -8x. So we're going to add 8x to both sides, and that's going to give us 11x's over here. Then we also have to move the -34 by adding 34 to both sides, and that's going to give us 10 plus 34, which is 44. And then from there, I think you can do that heavy lifting. Divide both sides by 11.
Who else? Tegan? Sure. Yeah, this is my least favorite kind. And this, I go back, this is what Jackson was dealing with a second ago. If it weren't for all these fractions buried inside this one and this one, then I would just fraction kill right now. But understand in this first step, we are not going to fraction kill. We are going to roll up our sleeves and say, I'm going to eliminate parentheses. Our goal in step one in problems like this is just to get everybody out in the open so we can go on the attack. You understand that we can't attack at this point because it wouldn't do us any good because those fractions are hidden from whatever attack we come up with, right? So in the step like this, all we can do is say, like, I'm going in. And that means, okay, on the left-hand side, I'm going to copy down this X because it doesn't have anything to do with anything, right? And then when I distribute this negative, I get plus 1/2 of X and I get -4, right? Do you see that that's just me distributing a negative? Then I'm going to copy down my -5. And then this is the part that no one likes, but again, I don't really care that we don't like it. We just have to know how to do it. This first distribution right here is no fun because it's like there's no hook, there's no rhyme or reason to this, but we have to still embrace the basics. That's a positive times a negative, so I'm going to put the negative before I do something stupid and forget. And since you see the numbers on top and bottom don't reduce at all, what do we get? Just multiply across the top and then across the bottom. What do you get? That's it. And it's so scary at first, but then you realize that, oh, wait, all I have to do really is just multiply. Yeah, multiplication is so easy once you get it. Top, top, bottom, bottom, boom. Reduce if you can. And then we're going to go again. And the problem with this second red arrow is that the 4 is not a fraction, but we can make it one. Yeah, so we're going to think of it now. And you can do this in your head or you can do it on paper. We have 3/2 times 4 over 1. And before we forget, why don't we go ahead and put our minus sign? Because again, we know that it's a positive hitting a negative, right? So just put our minus and we don't have to talk about it anymore. So over here on the left side, what do you think? Sure. Yes. So again, you could have reduced the 4 and the 2 right there, or just do it like you did it, get 12 over 2, and then don't be a ding dong. You know it's 6. Good job. Do you understand that first step? That had nothing to do with us having any specific vendetta against the fractions. That was us just saying, now that you're all out in the open, I just got my fraction license for the season. I'm allowed to bag as many fractions as I want. Unlimited. So I'm going to multiply by 4. And the key here is you got to go 1, 2, 3, 4, 5, 6. You have to multiply every one that's out in the open by 4. What do you think we're going to get?
Negative.
Minus. Keep going.
Now, 2 divided
going.
by 2 times 3 and -3 gives.
Yes. So you don't have to, because the thing about fraction, this is that hook I've been talking about, and each of you is going to hear it when you're ready. But the hook is how we fraction kill. And I know that the hook will work because you and I, we picked the number 4 that we knew would hook down and divide by the 4 successfully, right? So picture the hook happening, and then you don't have to do all this fancy stuff. Take the 4 that you're multiplying by, divide it down by the 4 on the bottom, you get 1, and then just multiply by that top, and you just get -15. The 4s essentially just eliminate each other. And then you still got to do 4 times. Good. What now? Yeah. So these are going to make 6x. These are going to make -36. And then you're home free. Add 15x to both sides to get those x's together. Add 36 to both sides to get the numbers together, and then divide by, I think it'll wind up being 9 or no, 21. You got it from here? Okay, just make sure you reduce your fraction at the end. Yeah. Yeah, sure. Just, I don't want to be in your picture, though. You?
Usually.
Sure.
I do have one.
Okay, so we have this negative measure.
Also, it's not, is it still on your screen though? Okay, good. So you've already done the problem. All right, so I'm just going to go through it kind of fast. You multiplied, I presume, by 12. And then you got 12 divided by 6 is 2, so you should have 2x plus 10. And then the next one, 12 divided by 4 is 3, so you should have minus 3x minus 27, and then equals negative 24. Now, I'm not a gambling man. I don't like that, but I would guess that if you messed up, it's because you put a plus right where I'm pointing. Is that what you did? Yeah, so the reason for that mistake, and I see it about 9,237 times per year, is that you guys forget, look up here, Landon, to take this minus sign and copy it down like I say to. And I know I just did this in my head. I'm setting a bad example. But when our fraction killer 12 divides by this 4, we get 3. But understand that this minus would have still already been there. And then when we put the 3 in front of the x plus 9, by having that sign there, do you see how the negative 3, not just it, of course, everyone gets this term right. Everyone gets minus 3x. That no one ever misses that. It's the 27 because the negative is like, I'm still here and you still have to distribute me to that positive 9 and make him a negative 27. You got that? And that's why I choose my words carefully. When I'm firm with you guys and I say copy that sign down, I do it for a reason. Okay. Yeah. What'd you do first? Yeah, if anyone's interested, this problem that Rutley has right now is, to me, the top of the mountain as far as poopiness goes. These are the ones that my heart goes out to you. I don't enjoy these problems. I do enjoy the challenge of trying to get you to learn them, but they're not fun. And the problem with this Rutley's question here is these fractions have like horns. If we were playing like Rock Band or Guitar Hero, this would be a song with like 5 red devil horns. If you play those games, you know what I'm talking about. This is expert level. So the trouble with this is that fraction inside, the 2/3 is like, you can kill fractions if you want, but I'm still going to be here. So this is my suck it up buttercup step where I say, I'm going in. And I tell you, if you can navigate a problem like this, you're in great shape. So what I'm saying to you is I can't kill fractions in the first step. Sorry. That is not my goal. My goal is to just take this 9/10 and distribute it to those. I feel like I've said this a lot, but I'm going to keep saying it because you guys hear things at different times when you're ready. Your goal in step 1 is not always to kill fractions. Your goal is to get the fractions out in the open so that you can then go kill them. So what I'm going to do, if I'm Rutley, is I'm going to take that -2, I'm going to copy it down. I'm going to take that negative x, I'm going to copy it down, and then I'm going to roll up my sleeves, take a sip of coffee, maybe pop my knuckles, stretch a little bit, and say, I'm sorry, this step sucks, but I'm going in. So what I have to do now is I have to take that first red arrow, which is 9/10 times -2x over 1. Do you see that? Why did I put -2x over 1? Yeah, I want fractions to go with other fractions. So that's why I did what I did. And so now what Rutley and I need to do is we need to multiply that little problem out over there on the left side of the TV. What are we going to get, Rutley?
I got 9.
Yeah, that's right. Good. So I don't know how, did you reduce the 2 and the 10 first, or did you reduce it later? Good for you. Good man. That's what I do too. So like this is -1x and then this is a 5. Smart thinking. So this is now -9/5 of x. If you can't do that, you're not dumb. You just don't know how to do it. And you need to vocalize to me. Say, come in at Flex someday or stay after school someday, or just come up to the desk someday and say, I'm really kind of sucking at that whole multiplying fraction thing. And I'll just help you. Like, that's what I do. And but that's not why I want you to struggle in my classes because of fractions. I don't want you to struggle at all, but don't let it be because of that. Now, Rutley, we have to go again, round 2. Now what we have to do is take that 9/10 and we have to multiply it by the 2/3. And I know it's a negative, so I'll just put the negative right now. So do you see any reducing that we can do on this one?
Yeah.
Again, the 10 and the 2 can play. So I'm going to take the 2 and make it a 1 and the 10 and make it a 5. What are we going to get? I mean, what are we going to get? Like, here's my problem. I'm putting a red box around it because that's what we're trying to do right now is 9/10 times 2/3. So what do we get? Like, what is 9 times 1? 5 times 3. 9/15. Do you see that there's still a 5 on the bottom? Are you sure?
Okay, there's your equal sign.
100%
We're gonna
sure?
bring down this.
If you wanted to, you also could have, because like right now I have a fraction that I need to reduce, and Rutley, we could have, look at where my green circles are going. I could have also reduced those by 3.
Yeah, that's what I did.
That's fine, buddy. So if you want to make this a 1 and then make this a 3, then we would have gotten 3/5. Because I was going to have to turn around here in a second and reduce this 9/15 anyways and make it 3/5. So now are we talking the same language? Okay. You feel good to this point?
So far with.
Okay, so let's fraction kill now. Let's multiply both sides by 5. What do we get, Rutley?
The negative. Negative.
And then
Negative x times 3.
and then yeah.
X, 5 times -2, -10.
Yeah, and also you're making a mountain out of a molehill in this case. Just cancel the 5s. What's left over? Yeah, so it's just -9x, and then do it again, bro. Don't make a big deal out of this. Just cancel the 5s. What do you get? -3. You still good from here? What do we do next? I'm sorry, what? What do we get? I don't know where we're getting derailed here, Rutley, but this, you just need to combine these terms, buddy. Just put those together. What do you get? You didn't put X's on your terms? Okay, that'll do it. So now when we put those together, we're going to get -14x -3. Then from here, you're going to add 3 to both sides. Divide, reduce, and there will be some reducing to do here for sure. Got it? I know some of you are already starting to backpack bandit me. I appreciate you 3 minutes to go packing up and making everyone else think class is over. Thanks for that. Hey, I will be here for Flex, of course, if you need me. I will also be here after school, of course. And you also know, Gunnar, did someone in your life give you the impression that it's polite to just sit there and talk to someone across the room while I'm trying to talk to you? I know you know better, don't you? But you show me that. I will also be here for Friday school. There are 3 opportunities coming up soon for you to get some help if you need it. I'm sorry, I can only get to so many of you at one time today. So take advantage of those extra opportunities if you're feeling a little overwhelmed. Right?
What is that?
Thanks, guys.
No, it's only gonna be- What do you do?